Hello everyone, welcome to lecture series on power system protection. Myself Rajeshwari Nananavar, working as assistant professor in the Department of Electrical and Electronics Engineering, KLS VDIT Haliyal. Today we are going to discuss the fifth module, lecture number 40. In previous lecture we discussed the protection against traveling waves, insulation coordination and basic impulse insulation level. In protection against traveling waves, as we discussed, these traveling waves are nothing but because of the lightning strikes on the station. So these traveling waves will be introduced into the line. So they will be there in the system only for a shorter period of time, but their effect will be very severe. So in order to protect the equipments of the substations against these traveling waves, we need to have a protective device, because these traveling waves will not be protected with the help of a shielding method, that is with the help of a ground cables. It is not possible to prevent the effect of the traveling waves. For that, in order to give protection against these traveling waves, we need to make use of the four different types of the equipments known as a rod gap, arcing horn, lightning arrestor, or also known as a surge diverters, and we use the surge absorber. The detailed explanation of all these points will be discussed in the previous lecture. Then also we discussed the insulation coordination, where it is a correlation between or the coordination between the insulation level of the equipment to be protected and the insulation level of the protective devices. So depending upon the insulation level of the equipment to be protected should be higher than that of the insulation level of the protective devices. So that we discussed, and also we discussed the basic impulse insulation level. So as per the ISI, so the standard level will be provided, insulation level will be provided for all the instruments in the power system. So these are the points we discussed in the previous lectures. Now moving on to the today's concept, the last concept of the fifth module, a very important, known as a gas insulated substation, GIS. So in this we are going to learn the different sections like components of the GIS, accessories of the GIS, classification of the gas insulated substation, and finally advantages and disadvantages. So after this lecture, the students will have a better understanding of what is the meaning of gas insulated substation, what is the difference between the normal conventional substation as well as the gas insulated substation, what are the different components this GIS system is consisting of, and what are the accessories we need to make use in the GIS, and what is the classification of these GIS, and finally moving on to the advantages and disadvantages of all these we are going to learn in the today's lecture. As per the Bloom's taxonomy, the today's concept comes under the understanding and remembering category level L1 and L2. So we'll begin with the C section of the fifth module, modern trends in power system protection. So though we have a substation, that is the conventional substation where air is acting as a insulation medium, air cooled substation. All of them are called as a air insulated substation, or a air will be acting as a insulating medium between the equipments. Now compared to that, what is the necessity of using this gas insulated substation? Okay, so that we need to understand. This is a gas insulated substation, or simply called as a switch gear. In short, it is called as a GIS. Conventional air insulated transmission and distribution substations are of a substantial size due to the poor dielectric strength of air. So as we already learned various or visited the various substations, so we have gone through that the size of the substation is very large. It requires a huge area for the construction of these substations. They also suffer variations in the dielectric ability of air to withstand varying ambient conditions and deterioration of the exposed components due to corrosive and oxidizing nature of the environment. So as these substations are directly exposed to the environment, because air is acting as an insulating medium, so they may suffer from the corrosive, or there may be a problem of oxidation. Okay, so because of all these, these substations are what we can say because of this corrosion or because of this oxidizing nature of the environment, so they are facing difficulties, or they are facing they are not giving a what we can say the reliable performance from this, or we can't expect a reliable operation from these air insulated substations. So in order to enhance the life and reliability of a power transmission and distribution substations, it is desirable to protect the substation components from a corrosion and oxidation due to environment. As I have already mentioned in the previous slide, that is, as these air insulated substation is directly exposed to the environment, so there is a problem of corrosion and the oxidation, so which may rise to a decreasing in the life as well as the reliability of the system. In order to overcome these problem and in order to enhance the life and reliability of the power transmission and distribution substations, so we are going to the modern trends in the power system. That is nothing but we need to provide protection to the substation components against corrosion and oxidation because they are exposed to the environment. So metal encapsulation of the substation equipment provides a simple and effective solution to the problem of durability of the substations. Okay. Since the size of the container or the enclosure is a direct function of the dielectric strength of the insulating medium, the container or whatever the enclosure we can call it as, the sizes are large with a medium of poor insulation such as a air or a nitrogen. So whatever the enclosure we are using, that is simply it is a air insulated, so directly exposed to the environment, so size becomes very large. The use of SF6 gas with a higher dielectric strength helps in manifold reduction in the size of the substation components. Now the modern trends, instead of using air as an insulating medium, we will be using the SF6 gas, which is having a multiple times the insulating property compared to that of the air. So with the use of this SF6 gas, the comparatively there is a drastic change reduction in the size of the substation. So the use of SF6 gas with a higher dielectric strength helps in manifold reduction in the size of the substation components. On the other hand, the grounded metal encapsulation makes the substation equipment safe. Here, the whatever the enclosure we are using or whatever the envelope we are using for these gas insulated substation, so that will be grounded. The grounded metal encapsulation provides substation equipment safe, as the live components are no longer within the reach of the operator. As the metal enclosure of the equipment is solidly grounded, it is directly connected to the ground potential, the electric field intensity at the enclosure surface is reduced to 0. So there is a no shocking action will be there. Okay, so there is a no chances of getting the shocks and everything. So the operator is safe. Using this design philosophy, various substation equipment such as circuit breaker, bus bars, earthing switches, isolators, CTs, PTs, etc. are housed in a separate metal encapsulated modules filled with the pressurized SF6 gas. So whatever the substations we can see normally, that is the air insulated substation, all these protective devices are directly exposed to the ground where air will be acting as an insulation medium. But in order to overcome the problem of oxidation as well as the corrosion, the gas insulated substation will be used, where the gas mainly used is a SF6 gas. So all these protective devices are going to be housed in a separate metal encapsulated modules. So they will be fixed up in a building on the floor, so where the SF6 gas will be acting as a insulating medium, that is a pressurized SF6 gas will be used as a insulating medium. The assembly of such equipment at a substation is defined as a gas insulated and metal enclosed system, GIMES. GIMES is popularly known as a gas insulated substation. So the assembly of all these protective devices such as a circuit breaker, bus bar, earthing switch, isolator, CT, PT, etc. So with the help of a pressurized SF6 gas, okay, is known as a gas insulated substations. So this is a pictorial representation of the gas insulated substations, which, as you can see, this is housed in a building and which is placed on the floor. Okay, so Just you can have a comparison between your normal substation what you have visited. So the size you can compare over here. Okay, so this is placed within the building. As you can say, this is a outermost surface of the building. So this all the equipments of the substations are equipped within the building. Okay, so like this we are going to reduce the size of the substation, and what are the different parts we have in this we'll see in the further slides. So this is a just a pictorial representation of your gas insulated substations. The various modules of GIS are factory assembled. As I have mentioned, in the factories we are going to use, in the industries we are going to use. So they are factory assembled and are filled with the SF6 gas. Therefore, they can be easily taken to site for a final assembly. So the different parts will be taken to the factory outlet or the factory site, where we can fit each and every part so that we can have a complete assembly, final assembly of the SF6 gas insulated substation. Such a substations are compact and can be conveniently installed on any floor of a multi-stored building or in any underground substations. Okay, so these GIS reduces the requirement for a space and improves the reliability, thus increasing its popularity for applications in metro cities, industrial townships and hydro stations where the cost of a space and the constructions are very high. Okay, so in metropolitan cities, as we are going to see, there is a no empty space will be there in order to construct the outdoor air insulated substations. So under those metropolitan cities or the industrial areas, industrial townships or the hydro stations, where the cost the land is not enough to construct such a big air insulated substation. So under all these conditions, for all these locations, these GIS are playing a very vital role. Okay, gas insulated substation is also preferred in a heavy populated areas where dust, chemical fumes and salt layers can cause a frequent flashovers in conventional outdoor substation. Okay, so heavily populated area means there is a if there is a industries or more and more vehicles are running. So in those areas it may affect, as these air insulated substations are directly exposed to the environment. So because of all these dust, chemical fumes or the salt layers are going to create a frequent flashovers in the conventional substation. So in order to avoid all these problems, we are going towards the gas insulated substations. The space requirement for the gas insulated substation is reduced to 1/6 as compared to conventional air insulated yard substation, that is 17% reduction in the space requirement. For a higher kilovolt class, size of the GIS is reduced to about 8%. So GIS covering the complete voltage range from 11 kilovolt to 800 kilovolt are internationally available. So these gas insulated substations we can have up, or we can operate for 11 kilovolts to 800 kilovolts, and these are available, readily available. So we need to take this parts separately, components separately, and we need to fit it in a buildings or the areas where you required. Then moving on to the modules or the different components of the GIS system. What are the different components these gas insulated substation may contain? So the following are the principal modules insulated by SF6 gas in a GIS: bus bar, isolator or the disconnector, circuit breaker, current transformer, earthing switch. So these are the 5 different components we have. Apart from this, there are auxiliary gas insulation modules or the accessories required to complete the GIS are instrument voltage transformer, surge and the lightning arresters and the terminations. So these are the different auxiliary equipments we do require. So this is a pictorial representation giving you the essential parts of a gas insulated substation. So here you can have a look. So this is a complete gas insulated substation. So the internal structure we are showing you. So the different part namings, the numbers have been mentioned, and each number is represented what is the equipment that is. Okay, so this is the first equipment. As you can see here, the bus bar with a combined disconnector and earthing switch. So the first we do have a bus bars where the incoming lines will be connected. Okay, the bus bars, this is a bus bar what you can see here. Okay, so here these are the bus bars. The second, circuit breaker. So this is a circuit breaker complete assembly consisting of a fixed contact and moving contact. This is a circuit breaker, second number. Then third is a current transformer. So this is a current transformer, what you can see. So I'll take a pen over here. So this is a current transformer, okay, CT. And the fourth one we have is a voltage transformer. Here we have these voltage transformers, complete voltage transformer. And fifth one is a line disconnector with the earthing switch. So this is a line disconnector with the earthing switch. As I have already mentioned you, these earthing switches are nothing but providing the low impedance path. Then sixth one is a make safe earthing switch. This is the make safe earthing switch component. Seventh one is a cable sealing. This is a seventh equipment cable sealing, as you can see here. And finally we have is a control device or the control panel. Again in this we do have a two different sections, local control panel as well as a remote control panel. Okay, so these are the different components which are there using in the gas insulated substations: bus bar, circuit breaker, current transformer, voltage transformer, line disconnector with earthing switch, make safe earthing switch, cable sealing, as well as the control devices or the control cubicles. So next we'll go one by one what are these different components and what for they are. So first we'll discuss with the bus bars. So the bus bar, which is one of the most elementary component of the GIS system, is of a different length to cater to the requirement of a circuit or bay formation. Coaxial bus bars are commonly used in an isolated phase GIS, as this configuration result in an optimal stress distribution. So coaxial bus bars will be commonly used in gas insulated substations. The main high voltage conductor made of aluminum or a copper is centrally placed in a tubular metal enclosure and supported by the disc or a post insulator at a uniform distance to maintain concentricity. Two sections of the bus bars joined by using a plug-in connecting elements. So this is about the bus bars which are going to or which will be receiving the incoming lines. Next we have is the isolators or the disconnectors. Isolators are placed in series with the circuit breaker to provide additional protection and a physical isolation. Okay. In circuit, two isolators are generally used, one on the line side and the other on the feeder side. A pair of fixed contact and moving contact form an active part of the isolator. So it is consisting of again one fixed contact and the one moving contact. Okay. So the fixed contact are separated by an isolating gas gap. Isolators are either on-load type load break switch or a no current break type. They can be motorized for a remote control or driven manually. Okay, so they will be controlled either with the help of a motorized, that is automatically we can control them, or we can control, or they will be run manually also. In GIS system, motorized isolators are preferred because automatic closure, opening as well as reclosing, it is very essential. So motorized isolators are preferred. Necessary interlocks are provided between the circuit breaker isolators and earthing switch. The next we have is a circuit breaker. Circuit breaker is the most critical module of the GIS system. It is a metal clad and utilizes SF6 gas both for insulation and fault interruption. So as we already discussed in the types of the circuit breaker, that is a SF6 circuit breaker, that too especially PUFO type SF6 circuit breaker are commonly used to accomplish fault current interruption in the GIS system. So as it is consisting of the movable cylinder where SF6 gas will be filled. So as and when the moving contact starts separating, this moving cylinder is also start separating, so that the SF6 gas gets compressed, and through the nozzle that SF6 gas will be released between the two contacts. So the arc interruption process will be begins. So this is the about the circuit breaker filled up where SF6 gas is used as a arc quenching medium. Then we have is a current transformer. The current transformer used in a GIS are essentially inline CTs. They are directly connected to the line. Gas insulated CTs have a classical coaxial geometry and consist of a following parts: tubular primary conductor. So the primary section is a tubular conductor, an electrostatic shield ribbon wound toroidal core, and gas tight metal enclosure filled with the SF6 gas. So this is about the current transformer. The next we have is a earthing switch. So earthing switches used for a GIS system are of two types: maintenance earthing switch and a fast earthing switch. So the name itself suggests maintenance means, so these earthing switches will be used for the maintenance purpose. So the maintenance earthing switch is a slow device used to ground the high voltage conductors during maintenance schedule. In case of any repair, so we need to take that part as a isolated. So under that condition, these earthing switches will be playing vital role. So for the maintenance purpose, these earthing switches will be connected to the ground in order to ensure a safety of the maintenance staff. Whereas the fast earthing switch is used to protect the circuit connected instrument voltage transformer from a core saturation caused by direct current flowing through its primary as a result of remnant charge that is stored online during isolation or a switching of the line. So in such a situation, the use of fast earthing switch provides a parallel low resistance path to drain the residual static charge quickly, thereby protecting the instrument VT from the damages which may be caused otherwise. Okay, so because of these remnant charges, instead of flowing them directly to the VT, the voltage transformer, instrument voltage transformer, so these earthing switches will provide a parallel path, low resistance path, where they will be flown through the earthing switch rather than flowing into the VT. So otherwise that VT may get damaged. So earthing switch is a smallest module and made of two parts: fixed contact located at the live bus conductor and a moving contact system mounted on the enclosure of the main module. So this is about the earthing switch. Now next we'll move on to the accessories of the GIS. What are the other accessories we will use in the gas insulated substations? Incomer and feeder connections form the main accessories of a substation. Incomer, that is the incoming line to the GIS, whereas the feeders are nothing but the outgoing line. So these are the two main accessories of the GIS. The supply is received at the incomer from a higher level substation or from a ring main. The power is received and delivered through either overhead lines or the underground cables at a substation. Air to gas and cable to gas terminations are employed as an interface to the two media in the GIS. Either we can have a air to gas or the gas to cable to gas. So these are the terminations which we will be using in case of a interface to the two medias in the GIS system. An instrument voltage transformer insulated by SF6 gas and used for metering and protection forms a part of the GIS. A gas insulated surge arrestor which protects the system from switching surges is a critical accessory required for the substation. So as we have already mentioned in the accessory, so other additional auxiliary equipments in the GIS system, that is a voltage transformer as well as these surge arresters, they will be used for protection of the GIS against the surges. Next comes the control panels. The control panels used in GIS are both local and remote types. The local control panel provides an access to the various control and circuit parameters of an individual GIS sections or the base. The local control panel facilitates the monitoring of gas pressure, status of the switchgear element, and operating fluid pressures of the oil, SF6 gas and air, etc. So this is the locally we can control all the parameters. Whereas the remote control panel is based on the microcontroller and its digital signal process can shrink the RCP to a single unit. So remote means far away equipments may also control with the help of these remote control panel. A man-machine interface, that different equipments will be using where a human is going to operate the machine. That is a communication takes place between the man and machines. A man-machine interface featuring bay-wise pages and many other similar functional integrations is the best techno-commercial solutions to the remote control panels. Connections to the central load dispatch centers or the central controls enhances the utility of an RCP. So load dispatch center or to the central control, we need to do the communication with respect to these substation as well as to the control center. In order to do this communication, various equipments or the machines we are using, such as a MMI, man machine interface, Baywise pages, or a similar functional devices we will be using. The next we'll move on to the classification of the GIS system. So the gas insulated substations are classified according to the types of modules and the configurations. So following configurations are generally used in GIS. Isolated phase or the segregated phase modules. It contains an assembly of individual circuit elements such as a pole of a circuit breaker, single pole insulator, one phase assembly of CT. A single phase circuit is formed by using individual components and pressurizing the element with SF6 gas, forming a gas tight circuit. A complete three-phase gas section bay is formed by three such circuits arranged side by side. So individually, by taking the individual components, we are going to make the one unit with the help of a pressurized SF6 gas. So in order to make such a three-phase, we'll take those such a three units side by side. So it will be forming the three-phase circuit. So that is a first isolated phase. Next we have is a three-phase common module. In this, a three-phase bay is assembled using the desired number of three-phase elements. The total number of enclosure is thus reduced to 1/3. Okay, so in earlier we used to have a separate what we can say, the enclosure for each unit. The separate enclosure will be there. So here in this common three-phase module, combining for the three modules, will be having a single enclosure. So the total number of enclosures will be drastically reduced to 1/3. By using a three-phase module, it is possible to reduce the floor of the substation up to 70%. Then we have is a hybrid module, which is nothing but a combination of isolated phase and a three-phase common elements. Then we have is a compact module. These compact GIS systems are essentially three-phase common systems with more than one functional elements in one enclosures. Then we have is a highly integrated systems. So these are single unit metal enclosed and SF6 gas insulated substations, which are gaining user appreciation as this equipment provides a total substation solution for outdoor substations. Okay, and finally moving on to the advantages and disadvantages of these GIS, very important. So first point is a compactness. GIS are compact in size and space required by them is about 15% of that of a conventional air insulated outdoor substation. So as I have already mentioned, how the size is going to be reduced. The compact size of GIS offers a practical solutions to vertically upgrade the existing substations and to meet the ever increasing power demand in developing countries. So as we know, in the developing countries there is no abundant space will be available. Okay, so within a permittable small space, we need to construct within the buildings, we need to have the substation. So these GIS are compact, we can say. So within the building we can have such a GIS modules. Cost effective, reliable and maintenance free. So GIS offers a cost effective, reliable and maintenance free alternative to conventional air insulated substations. Protection from a pollution. The moisture, pollution, dirt, etc. have a little influence on the GIS. Reduced installation time. The modular construction reduces the installation time to a few weeks. So already all the modules will be available. So we need to just make a connections between the different modules, so that the entire substation installation will become or requires a lesser time. Superior arc extinction or the arc interruption. So as we already learned, these SF6 gas are having a greater dielectric strength compared to that of the air. So the arc interruption or the arc quenching property is very much superior compared to the normal air insulated substations. Reduced switching over voltages. The over voltages while closing and opening line, cables, motor, capacitors, etc. are low compared to your normal conventional air insulated substation. So the switching voltages will be very less. Increased safety. As the metal enclosure of the various modules are ground potential, there is no possibility of accidental contact by service personnel to live parts. So as all this is a metal enclosure, so all the parts will be connected to the ground. All the enclosures of the various modules are directly connected to the ground. So the person who is operating with GIS systems, there is a less chances of getting the shocks or accidents will be reduced. Finally, moving on to the disadvantages of these GIS system. GIS has a high cost as compared to conventional outdoor substation. So it is having advantages as well as disadvantages, this cost term. In advantages, once we invest on this, it is going to give me a longer life period, whereas in the disadvantages, the initial cost, the initial investment on these GIS will be very high. Okay, has a high cost compared to normal conventional outdoor substation. Requirement of a cleanliness in GIS are very stringent, as dust or moisture can cause an internal flashover. So as we are using these GIS in an indoor, so the cleanliness of that particular area where GIS system is installed, it should be very clean. It should be dust as well as a moisture free. Since GIS are generally indoor, they need a separate building, which is generally not required for a conventional outdoor substation. So as this GIS is an indoor, it requires a specially designed building, whereas which is not required. So for that additional cost we need to pay, whereas these conventional air insulated, so directly it will be installed on the ground. GIS can have a excessive damage in case of internal fault, and there may be a long outage periods, as repair of a damages part may be difficult at a site. Okay, as these are placed indoor with the inside the building, so the repairing of the parts becomes very difficult. If I want to remove the parts, or if I want to take away the parts of the substations, little bit becomes difficult, where going to create a lot more damage to the other equipments also. Maintenance of a adequate stock of SF6 gas is essential. Okay, so we need to have a additional SF6 gas. Okay, what we can say, abundant availability of SF6 gas we need to ensure. So that SF6 gas storage and transportation is again causing a difficulty. So procurement of a gas as well as supply of the gas is a problematic in case of GIS system. So these are the disadvantages. Compared to all these disadvantages, it do have a lot many advantages. So it is acquiring more and more demand in nowadays compared to the conventional air insulated substations. So finally, moving on to the summary of the today's session. So today we discussed the gas insulated substation, what the modern trend in a power system. So why it is called as a gas insulated substation, what is its importance compared to the normal conventional substation, and what are the different components it has, accessories of these, classification, advantages and disadvantages. All these points we discussed, and with this we have finished all the 5 modules of the power system protection. So please go through this concept, very important, the gas insulated substations. And on this concept in the examination you may get a question, list and explain the components of the GIS system. You need to explain that 5 main equipments along with the auxiliary equipments, 3 auxiliary equipments, and explain the advantages and disadvantages of the GIS system. So 8 to 9 advantages you have and 5 disadvantages. You need to explain them. You need to first make a mention, then explain. Then explain the classification of the GIS system, that is a individual module, combined module, okay, so hybrid module. So all those 5 different classification you need to explain. So this is about the last part of your 5th module, gas insulated substation, that is modern trends in the power system substations. And for this section you can refer the textbook. Thank you. Have a nice day.